have found out the force vector by using the body force vector formula. Then by applying the boundary condition, we have found out that K as well as U. So K is stiffness matrix, finding elemental stiffness and then assembling the stiffness. We will find the global stiffness matrix. Then by applying the boundary condition, we will find the unknown displacement. U1 is 0 and U2, U3, you will be getting some value. So that is so far we have seen in this problem. So today we are going to see the stress, how to find the stress in this problem. So for each element you have to find stress, right? So in order to find stress, there is a formula. Stress is equal to E into the difference in the displacement. That is, for element 1 means U2 minus U1 divided by L1, right? This is what the formula. So here Young's modulus 1. Stress 1 is equal to Young's modulus into change in displacement divided by length of the element. So this is what the formula to be found, to be used for the finding the unknown displacement. Now here I am substituting the formulas. Listen here, substituting the values here. So what is Young's modulus of this problem? 2 into 10 power 5. 2 into 10 power 5. What is U2? According to the answer, what is U2? Refer to previous step. 9 into 10 power minus 5 minus
U1 into 0.
U1 is 0. Very good. Very good presence of mind. L1 is 300. Now you substitute and tell me the value of stress. What is stress? Sigma 1. Similarly, you have to find sigma 2, that is stress for element 2. For element 2, this is for element number 1. Element 2 is E2 into U3 minus U2 divided by L2. We substitute the value. The substitution is 2 into 10 power 5. What is U3? 1.1 into 10 power minus 4. What is U2? 9. What is stress for sigma 1? Element number 1 is 0.06. 6 is the answer. Is there any decimal point other than 6?
No, sir.
No. 0.06. The unit of stress is what? Newton per millimeter square. What is sigma 2? Stress of element number 2. Apply the values. Calculate it. 0. What is the answer? 0.013. Right. And the unit is again Newton per millimeter square. So this is how you will find the stress of the element for this problem. So sigma 1 is found out as well as sigma 2 is also found out. Forces. So the reaction forces, there is a formula, that is the reaction force R is equal to K into U minus F. So this is how you have to find the reaction forces. We need to find the reaction forces. You have to remember the data in the previous steps and you have to apply here. So I am applying the values here. So the stiffness matrix what I have found out is K is what? 1 into 10 power 6. Here 2.87. 187 here. 187 here. Here.
Minus 1.562. 0. Minus 1.562. 1.362.
This is what the K. And what is the U? U1 is 0. What is U2? 9 into minus 5. What is U3?
1.1 into 10 to the minus 4.
And what are the forces? 169. So this is how you have to find the reaction forces. So in order to substitute the value, you have to refer the previous step and you have substituted the values. Now what you have to do is you have to multiply the matrix. And what is the size of this matrix? How many rows and how many columns? I will count row 1, row 2 and row 3. So number of rows is 3. And number of columns, column 1, column 2, column 3. So 3 cross 3 matrix. And if you see that displacement vector, that is, you can see 1, 2, 3. So this is 3 rows and only 1 column, 3 cross 1 matrix. So if you are asked to multiply this matrix, you can multiply this matrix because the inner value is 3. So it can be multiplied. So how will you multiply? You have to remember the vector number 7. So how will you number 7? This row into this column. So I am multiplying here. Please calculate and tell me the values. Right? So the first value initially outside is 1 into 10 power 6. Right? 2.187 into 0. 2.187 into 0 is 0 plus 2 minus 2.187 into 9 into 10 power 5. It is minus 2.187 into 9 into 10 power minus 5 plus 0 into this thing is 0. Is it right? Next thing
0.
minus 2.187 into 0 is 0. 3.752 into 9 into 10 power minus 5 minus 1.562 into 1.1 into 10 power minus 4. The next thing 0 into 0 is 0 plus minus 1.562 into 9 into 10 power minus 5. Then next is plus 1.562 into 1.1 into 10 power minus 4. The whole value minus the force 40.39, 169.21, 28.8. So now I have to calculate it. Tell me the value of what is minus 2.187 into 9 into 10 power minus 5
Minus 1.96
into 10 power 6. Tell me the final value. Multiply again with 1 minus 1 into 10 power. So the next value. Next. And if you see here, you have to subtract these values with these values. That is 40.39, 169.21. Here it is 28.82. So if you subtract these two values, you will get the values of R1, R2 and R3. So finally, I am concluding this problem. So if we see R1, the value of R1 after subtraction is minus 238.15 Newton, and R2 is 0 Newton, and reaction force 3 is 0 Newton. So this is how I find the reaction forces, and this problem gets over. Thank you.